going to have a look at this question here, question 15, and we're having a look at essentially a specialist maths question relating to position vectors. And so we are given that points P, Q, and R have these position vectors respectively. So what we can say is that, okay, OP equals 2A minus B, OQ equals 3A plus B, and OR equals A plus 4B. Okay, so that's the first step there. And essentially that's just saying, okay, points P, Q, and R have these position vectors respectively. And whenever you're given something like point P, point Q, that's the same as saying OQ or OP. It just means from the origin to that point. Okay, then we know that the point S is on the line OP with OS equals KOP and RS equals MRQ. So for part A, it's asking us to express OS in terms of K, A, and B, and M, A, and B. So we'll start with part I. So if we want to express it in terms of K, A, and B, we're going to be using this little bit here, which has the K in it. So we'll start with OS equals K, which is just a factor of OP. Now, we already know what OP is because we were given that in the initial question. So we can say, okay, OS equals K times 2A minus B. And you can expand that if you want to say it equals, we'll just add the lines here to show that A and B are vectors, just to distinguish between K, which is a constant, and A and B, which are vectors. So you can say 2KA minus KB. So either way should be correct. Okay. Then we're looking at part 2, where we need to express it in terms of M, A, and B. Now this one's going to be a little bit harder because it involves RS and RQ, which we aren't initially given. So what I would do here is I would first try and find RQ. That's the first step. So, and I try and use quantities that we're given. So something involving R, O, and Q, similar to what we have here. Just checking still recording. Yeah, all good. Okay. So to find RQ, we can use vector addition in the following way. So we know OR, which means we also know RO. So we can say, okay, RQ equals RO plus OQ. That's the first step. And I will say, note that OR equals negative RO. It's important to consider. Okay. So we can say, okay, negative whatever OR was, A plus 4B plus OQ, which was 3A plus B. If I expand that out, it should just work out to be 2A 2A minus, and then B minus 4B, 2A minus 3B. And what I've done there is I've just expanded out and then collected like terms. Okay, so that's the first step. And then we know, okay, we know RS equals M times by RQ, which is 2A minus 3B. And that's just given to us up here in the question. Okay, so this is actually asking us to express OS, not RS. So the next step is we need to use this information here where we have RS and try and get back to OS. We can use vector addition once again. So what I'll do is I go, okay, OS equals OR plus RS. And we say, okay, what's OR? We're given that in the initial question. A plus 4B plus M 2A minus 3B, which is what we found just before RS. Okay, so from there, if I expand out, we can say, okay, we've got A plus 2MA plus 4B minus 3MB. And then you can combine the like terms here. Just say, okay, A is equal to 1 plus 2M. Sorry, OS is equal to 1 plus 2M all multiplied by A, and then 4 minus 3M all multiplied by B. Okay. So that's the answer then to part A, complete answer there. So now we're looking at part B, where we have to evaluate the values of K and M. And so what we can do here is we can actually use what we found in part A. So we know, okay, OS is equal to 2KA minus KB. There you go. So the K is a constant, B is a vector. And OS is also equal to 1 plus 2 all times A plus 4 minus 3M all times B. So we can actually equate these components. Which is a really useful skill to be able to use in vectors. So we can say, okay, we look at the A's, we can say 1 plus 2M is equal to 2K. And then B's, 4 minus 3M is equal to negative K. If we do a little bit of rearranging here, we can say, okay, K is equal to 3M minus 4. And what I did there was I just multiplied both sides by negative 1. Okay, so now we have this. So we'll call this equation 2. Call this equation 1. So we can say, okay, substitute 2 into 1. What we'll do there is we can just say, okay, 1 plus 2m, we know that's equal to 2k, and we've isolated k over here. So we can say, okay, that's equal to 2 times 3m minus 4. By doing some expansion, we can say that equals 6m minus 8. Do a little bit of rearranging, you get 9 plus 2m equals 6m, 9 equals 4m. So then m is equal to 9 divided by 4. And then what we do is we can just sub m into our second equation to find what k is. Let's go k equals 3 times 9 over 4, all minus 4, which should just equal, if I use my calculator, k is equal to 11 over 4. And there you go. That's the answer to part B as well. And so there is your complete